Yeah, today's topic is from theory to simulation. Okay, so this is something really interesting topic. So how typically engineers like a little bit more specifically power system engineers. Okay, they use ETAP in real time projects. That's what we are going to look at today. Okay, so let me jump in maybe before jumping into the topic, let me quickly give intro about myself. Yeah, about me, as you see here, basically, I'm an electrical engineer, right? So I have done so many projects with the different industries, right? And have trained more than 500 plus engineers, right? So literally I have worked for a few countries, that India, Kuwait, majority, most of the time India, Kuwait, Saudi Arabia, Europe, and UK projects, right? So I have a good experience in ETAP, CDGS, AutoCAD, and standards, right? So my specialties, if you look at, I'm good at substation design, earthing and lightning protection, power system studies, and EPC execution as well, right? So my mission, why I'm doing this, is very simple. Lot of engineers, they are yes, they are doing the work, but while doing the work, lot of questions. I mean, they have a lot of self doubts within their mind. So my mission is, when we completed our engineering, when we joined as a fresher, so we struggled quite a lot. And at the time, the technology what we have is not available at the time. And but we went through it, and we have learned so many steps. That's what we are going to sharing it. But now that all the knowledge what we are giving is back, and it will be quite useful for the youngsters and who are joining or starting their career, or mid career, who are in mid career, or who have completed more than 8 plus years. Definitely it is going to be quite useful, right? So with this aspect, my mission is to train engineers, almost 10,000 engineers. That's what I have started my plan. So, okay. So in that, I'm on the progress of, going actually, right? Great. So let's come to the topic now. Okay. So let me quickly understand from all of you guys that what are all the problems that you are having it while doing the system study, or if you're doing engineering or whatever it is. There are a lot of unknown parameters will be there. Agree with me, right? Agree with me, right? Right. So so how do you solve that? How do you solve that? How do you solve that? Just drop in your chat that what are the problems that you are facing in your project, right? So basically, maybe there will be a single line diagram. In that single line diagram, you maybe have to calculate the short circuit rating. Maybe you need to know that what is the real power is flowing. Maybe you wanted to know the what is the reactive power is flowing. Maybe what happens if the voltage is less, then what will be the current flow? What will be the power flow? You wanted to understand that, right? So these informations, this ETAP will give you by just clicking on single button. That's it. So you can do the projects in a real time, and you can validate that, and you can give the error-free engineering reports and calculations. So that's why ETAP, that's what ETAP, does, right? So some of the common power system problems that you are looking at short circuit level, we don't know. Motor, whether you are not sure that whether motor will start or not. We'll do the simulation and we will understand that what happens when you start high capacity motor in the bus and what are the parameters that it will impact. We'll come to know that, right? Then see, in a real scenario, you will understand by setting the relay and etc. You will be easily understand through ETAP. You will be easily understand that whether the relay picks up or not. You will be easily able to understand, and we can also ensure that what is the time discrimination between the main relay and backup relay, and we can also ensure that exactly 200 millisecond time discrimination whether you are able to give it or not, right? So that is one part of another advantage. And while running the load flow, there are maybe your transformer may be overloading, maybe your bus there will be under voltage, your cable might be exceeding the current carrying capacity, right? These all are problem. Like before you buying the equipment, you will be able to pinpointly able to do that and complete it. Agreed, right? So that is very, very important. That is very, very important. So ETAP helps you to solve that as well. And yes, when it comes about power quality, like when you have a lot of non-linear loads, what happens during the non-linear load? Then there may be third harmonics, right? Odd, like whatever that zero sequence harmonics. Then there will be a quite, your neutral will get overheated. Your transformer may get overheated because of the harmonics, right? Right? So, so all those things, it's a problem, right? So the challenge is ETAP will help you to check before even before even you buy the equipment and go and face the problem in a real practically, you can check that with the tool itself. That is why you need a ETAP, right? Then what about the safety of the switch gear? Like what happens when there is a fault happens or when there is a arc fault happens in the switch gear? So during the maintenance activity, there is a lot of accidents likely to happen because of that various reasons. So ETAP decides that what are the safety constraints and how quickly you are able to clear the fault, and based on these things and it calculates the incident energy, right, because of the arc fault, and ETAP gives that how much incident energy, and also it provides the that clearance diagram that how far that you need to stay away, and also that it gives the R plus labels so that you can paste it on them. And finally, based on the incident energy, you will be able to select the right personal protective equipments for the personal safety, right? So these are the real problems that ETAP, solves, guys, right? So, so that's what I'm looking at here. So, and with that, today I wanted to run through some, basic ideas, right? So, I'll quickly model that how the ETAP goes. So, I just wanted to show you that how ETAP calculates some, power system problem, right? So with that, let me go to the ETAP, right? Let me go to the ETAP. So now please remember that this is your ETAP tool. This is the your user interface. You're looking at on the top, you have all the file menus and you typical button, so many options and etc. And if you look at very carefully, this is you are in edit mode. And if you look at, these are the study cases. Various study cases are available, right? We are not going to all the session study now. We will do that basic how to model single line diagram, and we will run one load flow. Right? Simply we'll do. You start with simple, guys. Right? Right? So let's prepare that. Let's model one ETAP. Right? One single line diagram, ETAP single line diagram. Let's do that. So for that, let us understand one simple case. So let's say that we have a 110 kV grid, and let's say that after from 110 kV grid we are taking one 110 kV power supply that comes to 110 kV bus bar. Then after that, let's say that we have a transformer. Let's say that we have a transformer here, right? So which is 110 bar 33 kV, which is 110 bar 33 kV, right? So from the secondary side we have a 33 kV bus. So let's connect that. So let's connect it. So let's give some information to the transformer. So when you click on the transformer icon, here you can give the transformer ID, right? Then maybe you can switch on, switch off, something like that. Let's keep on now. Let's assume that it is in service. Go to the rating page. Go to the rating page. There you will find that primary side you are supposed to give 110. Then secondary side LV voltage, it is 33 kV. So you will give that. Then let's give the transformer rating is something 100 MVA, right? Let's give the transformer rating something like 100 MVA, right? So that is your transformer rating. So the moment you enter the transformer, you see that the ETAP populates the current on HV side and LV side automatically. So 110 kV side, the current is 524.9. Then 33 kV side, the current is 1750, right? At 33 kV level. So that's what it conveys the message. Now, for the transformer, these information may not be sufficient. You also need to specify few more data for the transformer. Let's go to the impedance page. In the impedance, you have to give the impedance, right? You need to give the impedance, right? So there is a positive sequence impedance, the negative sequence impedance that you need to give it, right? Then you have to give the typical XPR ratio. So these information that you need to get it from the transformer nameplate or test report. Just give me 1 second, guys. Yes. So let's continue. So basically from here, now we have given the impedance data. So this impedance, you are supposed to get it from the transformer nameplate or this expiry ratio that you need to calculate it from the your test reports, right? So this is the information. Then go to the grounding page, and you need to mention the your vector group data, right? your vector group data, then primary, and like you need to specify the winding part, then you need to specify the secondary part. I mean, what is the winding connection, whether it is star or, and you need to mention the system earthing also, whether it is a solidly earthed system or delta connected or whatever it is, right? Generally, on the 110 kV side, you will have the solidly earthed system, right? So let's give it like that, right? So let's give OK. And let's connect your grid also to the bus. So this is your the system, right? So now let's connect some load here. So let's add some load at 33 kV level. Okay. So we have a 100 MVA transformer. So let's add some data. Click here, you select unit kVA. Fix any one you want to fix it. So let's give the power factor is 90 or 85. Okay, let's give it 90. Then let's give some, uh, right. Let's give some data, right, 50 MVA. We'll keep it like that. Okay. So let's click OK. So this will be your 33 kV side load. And let's also add one more transformer. Let's also add one more transformer, right? And that, so that transformer you see here, let's connect it. So let's assume that this transformer rating is something around, let's put 5 MVA, right? So this could be a 11 kV supply. Then let's give that your impedance data and etc. Right? Info rating, right? Impedance, right? Then you give the typical data. And in the real projects, you need to give the actual one. Okay. So let's give some, vector group, right? Then click OK. So maybe to know the winding connection, you enable the symbol. So maybe you can disable, uncheck the font so that you will also get this information. Right? Great. Great. So maybe you can move it. If you want, you can move and you can connect it also like that. Right? Right. So now this is your load. Let's add some LV side also. Let's add some loads. So let's give some, LV side also, right? So let's take some load. Maybe let's give some information here. Let's give 90. So let's give 4 MVA load. Then let's click OK. Then let's give that load also. Now we have the complete model. So, so let's quickly save this. Let me click and bring it to the front page once again. Please remember that. Now, now, okay. Now let's run the case actually. So this is how you need to model it. So there is a grid. So also you need to give the grid. You have to give the rated kVA and the rated short circuit, right? Then you give the rated short circuit rating and etc. Right? So click on that. Click on that here, right? Then come here. Click on that. Okay. So let's make it happen like that. So now we have the system. So let's review once again. So we have a 110 kV grid and we have a 110 kV bus in our plant premises, and we have a transformer. The primary side of the transformer is 110 kV. On the secondary side of the transformer is 33 kV side. On the secondary on the 33 kV bus, we have a one big 50 MVA load, and apart from that, we have another feeder which is called one transformer feeder that has got 5 MVA transformer. On the transformer LV side, we have a 11 kV bus and switchgear. Then from the 11 kV side, and you have a 4 MVA load also, it is there, right? So that is our main system, right? So for that, what are the basic information that for this entire system? What we can do is, right? What we can do for this entire system is, what are the studies that we need to perform for that? Right? So let's put it like that. So what are the studies that we need to do? Okay. Let's put ETAP studies. So basically first what you need to do, SLD modeling first. First you need to collect the inputs, then you have to model SLD. Then let me put, you need to perform the load flow, right? Then you need to SAR circuit, right? Then you need to do, motor, starting study. You need to do motor starting study, right? Then you need to do, transient, transient stability. Then you can also perform, harmonic study as well, right? Then also you need to understand the final, maybe before final, you need to add relay coordination study, right? Then beyond then, what is that you needed is R plus study. So what I have listed is the basic studies that we are supposed to perform. But beyond, there are so many other studies that we need to do it. Okay. So many other studies that you need to do it. But to start with anyone, this is more than sufficient to cover all the aspects of power system. Right? So that is what the point. So with that, let me run load flow now. So we'll try to understand the load flow, right? So we'll try to understand the load flow and we'll figure it out how it works, right? Going forward, let me go back here. Please remember that one thing that you have to be very clear, guys. Okay. Because this modeling of single line diagram is very, very important. It's a one-time work. And the moment you complete this work, your model is almost 100% is accurate. Then hereafter you may have to revise it, but it's very less revisions that you may need. That is where this tool is very much, it is helpful actually, right? And you need to see it like in a long time, what all the things that you need, then in such a way that you have to make it, right? Right now, I have modeled single line diagram only suitable for load flow. Even you see that before the transformer, we need to put a circuit breaker. Let's add some circuit breaker also. 1 second. So let me add some circuit breaker, right? So let me bring some more circuit breakers, right? So this is how you have to add circuit breaker, guys, right? Then you need to define that what are the breaker rating and etc. So I'm just giving some idea that how to add it. Then you have to add the cable as well. Go to cable and put the cable here, right? This is how you have to add the cable as well. Now for the cable, maybe if you have to give some certain information. Let's say that this is a 50-meter cable. Okay. So the moment you click ETAP will, since this is 11 kV network, ETAP will automatically give you the 11 kV cables actually, right? You can select any one of that. Maybe you can select any one of something like that. Like I have selected 11 kV 3-core aluminum cable, which I have selected. Maybe you can increase the size, whatever that you need, something like that, right? So how many runs? Number of conductors per phase. So it is one only. We are giving at the moment one. If required, we will increase to later. Let's run the load flow, then we'll understand that. So we have modeled the cables as well. So this is the complete single line diagram that we have modeled it now. So now you need to run the study, right? Right? How do you do that? How do you do that? Click here. Go to, you see that this is edit mode. Click on that load flow button. Now you just click on that. The moment you click the load flow button on the right hand side, you will see a pop-up. So here you see that P and Q, there is a symbol. You can see that run load flow. Click on that. Then maybe you give the name of, load flow or something like that. Then run the case, right? So this is your, now it's going on now. Now, are you able to see that, right? So now, what is that you are able to understand here? What is the thing that you are able to understand from this flow? So this is what we call it as a load flow, or in other words, we can call it as a power flow, right? Let's try to understand. Let's try to understand that. So if you see here, let's try to understand that. See, maybe it is in complex form. It is showing actually P plus JQ. Okay. So let me put units here. So we'll enable the units so that you'll understand that what is your real power, what is your reactive power. So we have a 4 MVA load which is connected, but due to the voltage drop at the bus, you see that there is a power also it is coming, it has come down. So we have a 3506 kilowatt, and this is the kVA that it is at the moment it is drawing from the grid. So we have a under voltage in this bus. So 93, it is supposed to be above 95 degree, sorry, 95 percentage. And if you look at in the bus 2, which is 33 kV bus, we have a, it is supposed to be above 95. That means it is okay. And marginally, it is very close. And that's why it is showing in other color. It is marginal. But this is something that we need to look at. This we need to fix it. This one we need to fix it because here there is a under voltage, right? That is why here also there is a red. So this is under voltage. So now going above, if you look at, there is a transformer. Now on the left hand side, so from here, the transformer rating is 5 MVA. What you are having is, okay, let's change it, switch to the KVA mode. You see that there is a 5 MVA, and what is that we are drawing from grid is 4 MVA approximately, right? Then here also there is a 5 MVA, then we are getting almost 49 MVA power. So all together, if you sum it up, so the totally we are getting 53 MVA. Okay. Let me put the unit also in MVA, right? So 53.4 MVA. So that is quite useful, right? This tool. And the transformer rating is 100 MVA. Then on the other side, if you look at, so maybe you are you able to see that now, right? So 53.4, then suddenly it has become 55.2. Do you know why? Do you know why? Because it includes the transformer losses as well, right? It includes the transformer losses as well. When you enable the losses, you see, you'll be able to see the losses as well. So that is why it is extra 55.2 MVA that you are drawing from the grid. So this is your the power flow. Now the problem what you need to solve is you need to adjust this bus and you have to resolve it. Let's try to adjust that. So we have a tab system. We have a tab. So we'll try to adjust the tab so that here we have in the transformer always on-load tab charger will be there on the primary side of the winding. So let's try to adjust that, right? So let's go to the transformer tab. You see here there are two options available. One is fixed tab, another one is automatic tab, right? So let's try to use this. Generally there will be a, okay, we'll try to use the automatic. Click on here. So we'll try to give both side 5% tab on the plus or minus 5%. So let's try to give that. Okay. So click OK. So you need to select the what is the bus that you wanted to regulate. So we are regulating on the LV side bus, which means bus 3. So click OK. So because bus 3 is the problem for us. Click OK. Right. So now let's try to rerun the load flow. Let's see whether this is getting adjusted or not. So it is running now. I hope you are able to see that now the bus voltage has become 98.5, right? So that means now it is fine. It is absolutely fine. So now the system is stable now. So if you wanted to adjust on this side as well, maybe here also, maybe the similar way you can update. But here there is let's give some bigger range. So this also will get adjusted, right? So this is how you need to work on, guys. So you see that this is also 99.94%. So when you adjust the tab, this is very, very important. So there will be a OLTC on the primary winding. So when you adjust the tab so that your to regulate the your secondary bus or on the LV side, whatever that bus is there, no 33 kV switchboard, you can adjust the voltage as well. So that is how you need to work on that, right? So I hope this is how you need to run the case, guys. You have to solve the problem like that. So that's what I was explaining here. So here you can also see that real workflow. What I have shown is a simple steps, but there are quite a lot of information is available. It's a powerful tool that which from which we can learn quite a lot of things actually, right? So I hope this will be the your key takeaways. So right, so that modeling part, how we have to put it, I have added. So how theory meets practice means, this means whatever that you're studied in the college or whatever that you are understanding, now practically we are putting it and we are running it whether it works or not, right? So that how it comes, we need to work on ourselves, right? So that you can get better on that. So in additionally, if you want this session for as a complete recording, okay, you can share your key takeaways from this session and tag me and our company web page so that you will get the complete recording session. So that you can watch it at whenever you need, right? So that's my gift to you guys, right? So you can take that. So apart from that, I wanted to give one more information. So to if you want certificate of participation for this particular webinar, okay, particular webinar, you can also fill that and you can fill that. You can automatically get the certificate webinar participation certificate, which also you can share it in the uh, LinkedIn and along with your key takeaways so that you'll get the free recording to you, right? So that's one part. I'll share the link shortly, right? So once again, let me share the link quickly for you and just give me a moment. So those who are interested, I have shared in the chat. You can also go through it and let me go back to the slides quickly, right? Great. So now let me go back again. So this is your this thing. Then next I wanted to give one more information. So we are running so many courses, out of which already substation design course already we have started. Two classes are over. April 25th. I mean, which means yesterday we have started the course. Today also the second day completed successfully. So you can go through it. Additionally, if you wanted to attend this, you can buy it at 30% offer and say that it is only based on the exclusively since you are attending this webinar, we are giving this offer to you guys. And of course, the ETAP, we are going to start new course from our company. So for the early bird offers, we are giving 50% offer. So if anyone, it's a 30-day course. I'll give you the details now. It's a 30-day course. Course starts on, sorry that I have put a 7, actually, June 1st, actually, June 1st. So let me edit the date, actually. It's a June 1st. It's a June 1st, right? It's a June 1st. And every day, 7 p.m. to evening, 7 p.m. to 8:30 p.m., 30 days course that we are starting it continuously, right? Every day. So that's those who are interested, they can join. It's online and you can attend it from anywhere and you will get the recorded session and you can watch it and you can practice it at your own pace, right? So this one we have already started weekend batch. So 3 months course, morning 10 a.m. to 1 p.m. that we have already started. So you can avail this course actually if anybody wants. And also you can refer it to your friends also. You will get some commission on that, right? So that's all. And those who are interested, please reach out us so that we can help you out to enrolling all those things. And if you want this record of this session, then share your key takeaways. And apart from that, you also get the certificates also. Yeah, Subham, we will share the details to you. Okay, we will share the details to you. Our team will share you the complete course structure. Okay, we are going to cover all the modules actually. Okay, and the fee structure also we will share it. And those who are joining, they get 50 percentage. So that offer is already there. Okay, so you can avail it, and my team will share the complete structure for you. Right? One second, I will show you the website also. You can go through that. Right? Just give me a moment. Let me share our website also. You can go through our website. Right? So let me share it. I'm not sure that my team has put it. Let's do that. You go to the training page, wherein if you go and you can see the details. And yes, we will give the separate information as well. Okay, so like here you will get the all the details. Okay, so the entire the detailed course curriculum we will give you that. Okay, Those who are interested, only for them we are sharing it actually. And this is the course price. Those who are joining first, I mean yearly, flat 50% offer. Okay, flat 50% offer. It's a 45 hours class, fast track. What is needed to run the study, that's what we are giving it, right? So it starts on June 1st, Monday onwards, every day that we are going to do it, right? So please, like our team will share the complete details. So if you have any questions or anything, please reach out. They will help you out, right? So apart from that, so claim your certificates, right? Share the your key takeaways from this session and put it in the LinkedIn and share the certificate as well. And definitely use these codes. Use these codes so that you will get an offer, right? And this is valid for 2 days. Sorry, 48 hours, right? You can avail it at any time. And yeah, that's all for today, guys, right? So any questions? Any questions? If you have any questions, you can unmute and you can ask. So that's all from my side. So we can discuss. I can answer any questions means. If no questions, then we'll wind up the session. Right? Hope today's session is useful. I hope today's session is quite useful. So like that, you need to perform each and every studies, guys. So I'm going to talk about all the studies. What are the studies we are going to cover? Load flow, short circuit, motor starting, transient stability, harmonics, relay coordination, arc flaws. This is the one, right? That's a basic study that anybody has to understand, right? Yeah, that's all. That's all from my side. Why motor acceleration studies need to be done if all these have been considered during the switchgear calculations? Yes. So, when we say switchgear calculations, see, you will put the, maybe you will give the circuit breaker rating and you will put the short circuit rating and etc. But please remember that in a real situation, when we say 110 kV voltage, we will never get 110 volt, voltage in the grid. There may be a plus or minus 5% or there may be a difference. Actual voltage will never get it. What we are saying is a nominal voltage. So when such cases, so there may be a up and down the short circuit level also depending upon the grid, it changes. That is one factor that we need to look at. And it is not a permanent one or fixed one, it is a variable thing. And second, in the switchgear calculation, you are not looking at the motor torque. Why we are doing motor starting study? Because when you start the high voltage, high capacity motor in this thing, there will be a motor will consume lot of reactive power in that during the starting. Then at the time, it should not, that means in the system, there will be a huge voltage drop or voltage dip, we can call it. So that voltage dip, the other, whatever that other loads which is connected in that bus, no, that also will experience. So now there is a huge impact, right? So that we need to check it. That in the switchgear calculations, we may not be able to do that. That only by doing the motor starting analysis, that only you will be doing it, right? Apart from that, motor starting study also required so many things. How do you select your starter? How do you select your switch, motor starter? When you need DOL, when you need star delta, when you need VFT, when you need auto transformer. So that those things you can check and you can define it. And also you will, from the motor starting study, you can also check that when you start high capacity motor and how much voltage drop exactly you are getting it, that you will see, you will be able to see it there. And also whether if you start the motor, whether the motor starts or not, that also how long it takes, what is the motor acceleration time, that also you will be able to calculate it. These things will not be available in the switchgear calculations, but you can do it in the ETAP. But that is also very essential to discuss in the project. I hope now you understood the importance of motor starting study, right? Motor starter is defined on basis of process need to as well as motor ratings. Motor, see, based on the process team, they say that I need a motor. That's it. They'll give the brake horsepower. That's it. They will say their application. That's it. Based on that, you need to choose the right motor with the right torque, which should be suitable for your process load. Those complete, it is on us only. How do you do that? With this only we have to do it, right? So it is not just torque criteria is the important one that you need to look at. Apart from that, there are other factors also it is there. Like, you need to look at the speed, you need to look at the right mounting arrangement, you need to look at, necessary, what do you call, starters, you need to look at that motor duty. Likewise, so many other factors that you need to look at. So that is why we need a motor starting study. So in that, the major parameter, these things you can check it. I hope that answers your question, right? Any other questions? Is that clear? Subham, please confirm, is that clear to you or you need more explanation? If it is clear, just put CC in the chat so that I can understand that you got it. Yeah, yes, that's clear, but still, what is that still? What is that it is bothering? Let me help you out. And in a ETAP, when the short circuit is less or whenever that under voltage happens or grid voltage goes below 95%, then what will happen? That you can check it. These are all the options in the motor starting that you can do. What is that your question? You tell me. I will explain. Process needs to decide variable torque requirement. Okay. Okay. So you see that torque requirement is something. Let's say that, see, there is a pump, there is a conveyor. Pump operation is different. Conveyor operation is different. So you need to understand that first process side, that means mechanical side, what kind of application and what is the torque requirement they need, that you need to understand first. Whether they need a constant torque or whether they need a variable torque, that you have to understand first from them. Or do they need any speed requirement? You have to understand from them. The moment you understand from them, you have to get two inputs from them. Torque requirement, you have to get it. Another one, they are supposed to share the breakers power. With these two information, then you can calculate for your motor starting torque. Based on that, you can choose your motor. Yesterday only I have taken one session based on how to select right motor based on the mechanical load and etc. We have made a session. If you want, you can also go through that. Please visit our website. There you will find that. Okay, this is how you have to select actually. And of course, because the application point of view, we have to be very clear. You need to understand their application. That is very crucial. So that will help you to select the right motors actually. Right? Clear, Subham? Is that fine? The soft starter is the one, basically, if you wanted to start the motor in a smoother way, right? You wanted to ramp up motor speed very slowly, torque wise, then you need a soft starter, right? So for the smooth starting, you need a soft starter. That is why it's called soft starter, right? But after that, it will become a normal one. That's it. That is only to align that during the starting time. You need to limit that. That's why you are using that soft starter. That's it. Those study also, it can be done in the ETAP. Out of 4 starter, which is best? You can go through that. You can do that. Yeah, your climb is correct. So it helps you to start smoothly. You can ramp it very slowly. Smoothly you can ramp your motor. That's why it's soft starter. Right. Hope that in relay coordination for LSIG settings, when to prefer short time to instantaneous according to the load. Please remember that. So in LSIG, so I means instantaneous. Instantaneous you have to select for the end loads. That means from where only you are starting your setting. For example, from the motor or the last feeder. For that you have to start I. That means whenever the fault happens, immediately you have to trip. Then above and above, you will have other loads also. That means you have to use short time also there, right? So that means why you need a short time in between, because let's say that in one of the switch gear you have uh, say for example in the MCC all the outgoings are motors, and in the incomer in all the outgoings you can set instantaneous, but incomer you have to set short. So because for this you need to have a coordination, right? So you need to set like that. So basically that is a release. So the release to release, there shouldn't be a overlap. If you ensure that, that means your setting is correct, right? Is that clear? So the end loads you have to give the instantaneous. Whatever that load it is in between it is coming, no, don't give that. Is not required. So you have to give the short setting. Do you use them simultaneously for same feeder? Yeah, sometimes we can use it, no problem. You can use it, but as long as it coordinates with the other one, actually. I mean, the downstream one, right? But instantaneous, the end for it should be used for the end one only. That depends upon the situation. Every situation it changes. So try it, you will understand. So try to do different cases and try to understand. It is not required. See, let's say that when the incomer, if you give an instantaneous setting, when the fault happens in the downstream or in the bus, the entire outgoing loads will be disconnected, right? Then there you should not use instantaneous setting. Very simple. I'm giving some tip to you. You can use it. So that's why I'm saying end loads only you have to give instantaneous. The upstream, when you're going up and up, you have to use only short setting. That's it. Right. So hope that clear. Yeah, thanks, Subodh. Okay, see you then. Next week we will join with another. If you are interested in that courses, please reach out. That will be able to help you out. Yeah, thank you guys. Thank you. Thank you so much. Yeah.